Students, in the last period we have started about the topic materials, metals and non-metals. And regarding the metals and non-metals, we have studied the various points. For example, metals are hard and lustrous. Then non-metals are brittle and you can say they are not lustrous. Then metals are malleable. Malleable means the property by virtue of which metals can be converted into thin sheet is called malleability. So metals like iron, copper, aluminium, gold, silver, etc. These metals are malleable and you can say can be converted into thin sheet by hammering. And you might have seen the blacksmith heat the various gold, you can say iron article, and you can say by hammering it acquires the required shape of the instrument. For example, axe, spade, etc. Then next property of the metal is ductility, that is metals can be drawn into wires, and the property by virtue of which the metals can be drawn into wire, thin wires, is called ductility. And thus you can say that the metals are ductile, or metal possess the property of ductility. And see, metals are highly malleable and ductile. That means 1 gram of platinum or gold can be converted into wire of 1 or 2 kilometer length, isn't it? So thus metals are highly malleable and ductile. Then next property is that metals are, you can say, good conductor of heat and electricity. Now I have told you this point. For example, take the metal bar, and if the metal bar is heated at one end, then other end of the metal bar also get heated. It becomes hot. How it becomes hot? Because the electrons in the hotter region acquire heat energy, and you can say their kinetic energy increases due to absorption of heat, and these electrons from hotter region move to the colder region, and thus the other end of the metal or the colder part of the metal bar also get heated within a short time. And in this way metals are good conductor of heat, and metals are good conductor of electricity. You know, electric current is nothing but free flow of electrons. Free flow of electrons. And thus electron moves, for example, in this direction, the positive charges move in the opposite direction. And thus metals are good conductor of heat and electricity. Then you can say we are using the copper wire, aluminium wire, etc. for electrical conductivity. We are using copper wire for our electric fitting in our home. And similarly, on the road, there are various electric poles and their aluminium wires are used, etc. So metal like, you can say copper, iron, gold, silver, etc., magnesium, all these are good conductor of heat and electricity. Clear? And while about the non-metals are bad conductor of heat. For example, coal never carry the electric current. Then you can say other non-metal, sulfur, etc., never carry the electric current. Phosphorus, oxygen, then nitrogen, then you can say carbon monoxide, carbon dioxide. What would have happened if these non-metals would have been good conductor? Then if the non-metals like oxygen, hydrogen, nitrogen, carbon dioxide, you can say nitrogen, phosphorus, if they would have been good conductor of electricity, then we would have been no more on this earth, isn't it? So remember, this is the nature's arrangement. So non-metals, and you can say non-metal, nitrogen, oxygen, hydrogen, etc. are, you can say, that coal or sulfur, phosphorus are bad conductor or poor conductor of heat and electricity. Then you might have studied that the metal produces sonorous sound. That is, when the metals are struck by hard material, they produces the sonorous sound, isn't it? That is ringing sound, and therefore metals are said to be sonorous. But coal, sulfur, when they are hit or when they are struck by any hard material, they do not produce the ringing sound, and therefore we say that non-metals are not, you can say, sonorous, isn't it? So in this way we have studied the properties of metals and non-metals. Then another important property that we have started, that metals when heated in air or in atmosphere, then air, you can say, reacts with the metal and forms its oxide. For example, magnesium, twice Mg plus O2 giving heat. This is the sign of heat. So this is the sign of heat, twice Mg plus O2 giving twice MgO. Then you can say twice Cu plus O2 giving twice CuO. Then you can take the different metals, sodium, for example, 4Na plus O2 giving twice Na2O. Then you can write 4K plus O2 giving twice K2O. So see the balancing of the equation. So here oxygen atom are 2, here we have taken 2 oxygen atom. And why this formula here, formula magnesium oxide is MgO, because valency of oxygen is always 2 and valency of magnesium is 2, therefore MgO. Valency of copper 2, valency of oxygen 2, CuO. Valency of sodium is 1, valency of oxygen is 2, therefore 2 sodium atoms will combine with 1 oxygen atom and will form Na2O. But for the balancing purposes, we have given 4Na, 4K. So you know, in the periodic table, for example, lithium, hydrogen, lithium, sodium, potassium, rubidium, cesium, they are placed in the first group of the periodic table, and their outermost shell contains only 1 electron, and therefore on getting energy, lithium, sodium, potassium, rubidium, cesium, francium, they possess only 1 electron, and therefore we can say that they are monovalent. And similarly, iron when exposed, for example, iron metal, iron plus water plus O2 gives iron oxide. Iron oxide. And this process is called rusting. The process is called rusting. Then in this way we can study that magnesium oxide, sodium oxide, then copper oxide, potassium oxide are found to be basic in nature. So sodium oxide, potassium oxide, all metallic oxides are basic in nature. How? For example, take the magnesium oxide, which is called now magnesium oxide MgO. When it is reacted or dissolved in water, and see the magnesium hydroxide is formed. So this is magnesium oxide and this is magnesium hydroxide. And this so see, magnesium oxide, for example, take the magnesium ribbon first, burn it into air. Magnesium, you know, magnesium metal burns with dazzling flame, that is brilliant white flame is produced, and finally white ash is left, and such white ash is taken in the test tube and shaken with the water. Then MgO plus H2O gives MgO by 2, magnesium hydroxide. And this magnesium takes the nature of magnesium hydroxide with the help of litmus paper. So for example, if you will take blue litmus paper and touch to the solution of magnesium hydroxide, there will be no action on the blue litmus paper. But magnesium hydroxide solution, when touched with the red litmus paper, turns blue. So solution, we can write solution turns red litmus blue. So solution turns red litmus blue. Clear? So in this way, copper oxide Na2O. For example, we can write the reaction of Na2O plus H2O giving twice sodium hydroxide. This sodium hydroxide also turns red litmus paper blue, and therefore we can say that metallic oxides are basic in nature. All metallic oxides are basic in nature, and therefore in contrast to metallic oxide, non-metallic oxides are acidic in nature. So remember, these are the most important sentences, most important points regarding the chemistry. So metallic oxides are basic in nature, which turns the red litmus paper blue, and non-metallic oxides are acidic in nature, which turns the blue litmus paper red. So these are the important points, and we can say we can carry out the experiment. Magnesium oxide ash is taken in the test tube and water, and shake the test tube. Magnesium hydroxide solution will be obtained, and then this solution is touched with the red litmus paper and it will turn blue. And in this way we can confirm. In this way, take different metallic oxide, prepare their solution in water by taking them into test tube, adding 2-3 ml of water, and shake them with the metallic oxide and touch with the red litmus paper. So red litmus paper turns blue, and in this way we can show. Then another important point is that copper. So copper also, when exposed copper vessel, for example, twice Cu plus H2O plus CO2 plus O2 gives CuOH by 2, CuOH by 2 plus Cu plus CO3. This is called basic copper carbonate. Basic copper carbonate. This is copper hydroxide. This is copper carbonate. And as the nature of copper carbonate is basic, therefore we say it is basic copper carbonate. And the copper, which is brown in color, becomes here. There is a deposition of copper carbonate on the copper vessel, which is having pale green color. And in this way, copper also gets rusted. Then silver, for example, silver. So this is silver metal. Silver having symbol Ag. We have taken 2 molecules of silver plus, you can say, sulfur, S. So this is sulfur, and we get Ag2S. We get Ag2S, silver sulfide, which is black. Silver sulfide, which is black. So learn by heart these chemical reactions, and these chemical reactions will be helpful in the 10th standard. So silver, metallic silver, if used continuously, then it combines with the sulfur and form black color silver sulfide. SuLPHRDe is having black color, and in this way there is a rusting of the metal, and we have studied the metals when heated with oxygen, they form their oxide. The metals when comes in contact with the moisture, oxygen, etc., with the atmospheric gases, then they form their oxide. Oxides are finally converted into hydroxides. So we have studied the reaction of sodium, potassium, magnesium, copper, etc. So copper also, for example, copper having brown color, twice Cu plus O2 heating gives twice CuO, and copper oxide is copper 2 oxide or copper oxide having black color, note down, twice Cu plus O2 giving twice CuO, and this is the CuO having black color. Then about the activity of non-metals. Now about the activity of non-metals, for example, non-metals do not, again I have to, about the non-metals, for example, non-metals on heating, what they form? They form their gases. For example, coal will form carbon dioxide. Coal when burned will form carbon dioxide. So C, coal or charcoal plus O2 giving CO2, and CO2 plus H2O, for example, use H2CO3. This is carbonic acid. Now see, then sulfur plus when burned, how the sulfur is burned. For the burning of the sulfur, we take deep grating, you can say spoon. Deep grating spoon is like this. For example, like this. And we take the sulfur here. So sulfur powder, and ignite the sulfur powder. So this is sulfur, and it is heated, so it starts burning. And therefore, as soon as the sulfur starts burning, you can say introduce the spatula, or you can say this deflagrating spoon. Deflagrating spoon into the gas jar, and put the lid on the gas jar so that the sulfur dioxide which is formed will not escape out, and then by removing the lid and some quantity of water, for example near about 10 to 15 ml of water, and put the lid and shake so that all the sulfur dioxide which is present in the gas jar get dissolved in the water, and then test the nature of water or the solution which is formed. Now see, S plus O2 giving SO2, sulfur dioxide, and SO2 plus H2O giving H2SO3. Now H2SO3 is the sulfurous acid. So this is sulfurous acid. Now in order to test the nature of the sulfurous acid, take the blue litmus paper, touch the solution of sulfur dioxide, that is sulfurous acid, and this sulfurous acid turns the blue litmus paper red, and again carbonic acid, which is formed by the dissolution of carbon dioxide in water, touch the blue litmus paper, will turn red, and in this way oxides of the non-metals are acidic in nature. So remember, oxides of the metals are basic in nature, oxides of the non-metals are acidic in nature. So these are the important points, and in this way you can carry out the experiment for phosphorus also, then sulfur, etc. So these non-metals, sulfur, coal, charcoal, graphite, diamond, etc. All these are the different forms of the carbon. Then sulfur is solid, phosphorus is solid. So these solid non-metal, they on heating get converted into their oxides, and oxides when dissolved in water form acid, and this acidic nature of the non-metallic oxide can be proved by litmus paper. So here we can say that blue litmus paper turns red, indicating that non-metallic oxides are acidic in nature. Clear? So again, this is the important point. And about sodium, potassium, lithium, rubidium, cesium, francium. So these are the alkaline. So these are the alkali metals, and these alkali metals like sodium, potassium, they are highly reactive. They are very sensitive to the atmosphere, because sodium is soft metal, potassium is a soft metal and can be cut by knife, and if they are exposed to the atmosphere, they immediately combine with oxygen to form sodium oxide, to form potassium oxide. Just I explained it. And sodium oxide further reacts with moisture to form sodium hydroxide. Sodium oxide reacts with moisture to form sodium hydroxide. Potassium oxide reacts with water to form potassium hydroxide. So in this way, these are exceptions, that is, these metals are soft and can be cut by knife, and therefore these metals are kept or stored in kerosene in laboratory. They are not stored in water, but we have to take the kerosene in the bottle, and then we have to add the sodium or potassium metal, because sodium reacts with air, sodium reacts with moisture, potassium reacts with air, moisture, etc. and therefore these metals are stored in kerosene, isn't it? So you have to take the kerosene in the bottle and you have to store it, isn't it? Then this is about the important point. Then about non-metals. So non-metals do not react with water. Non-metals do not react with water, and therefore they are stored. They can be stored in water. For example, coal or charcoal do not react with air, moisture, etc. Therefore it is kept open or can be stored in the water. But sulfur do not react with air and moisture, and therefore it can be also be stored in the water. But phosphorus has two allotropes: red phosphorus, white phosphorus, 2 or 3 allotropes: red phosphorus, white phosphorus, yellow phosphorus, etc. And phosphorus is also highly reactive. When exposed to the atmosphere, it starts burning, and therefore the phosphorus non-metal is stored in the water. Sodium, potassium, they are stored in the kerosene, while phosphorus, all the electrons of the phosphorus are stored in the water. For example, water is taken inside the water, and you can say phosphorus metal is kept inside the water in order to avoid its oxidation, its reaction with the air and moisture, particularly air, because it starts burning in air and therefore we keep it under water. So this is about the next point. झालं हां
बंद करू
कार्यक्रम आहे तिकडे कार्यक्रमाला बंद करा
हां बरं झालं का
झालं